Welcome, Algebra 1 to 2.2, solving one-step equations. Hey guys, I hope that you guys have seen the things that I'm about to present in here before, at least most of it. This might be a big review for many of you, but that's okay. It's a good review. So we're going to get into some golden rules of how to solve equations in algebra. Just making sure that I'm recording here. So here's what we're going to do, guys. Let's go over some rules, and then we're going to get right into solving some of these things. Okay, so the golden rules. Okay, I want you to think of an equal sign in algebra as kind of like a scale. One of these scales where, I'm a terrible artist, but if you have one of these scales where, if you put a weight on this side, the thing drops, right? And this side goes up. But then if I put the same amount of weight on this side, it comes back into balance, right? So if you think about an equal sign as like one of these scales, where whatever I do to one side, I have to do it to the other side for these things to remain balanced. When you see an equal sign, that means that the scale is currently balanced. Okay, so when you see an equal sign with like an x, if I say like 2x is equal to 9, for instance, what that's saying is the 2x and the 9 are balanced. Okay, that means that x has a very specific value that we can solve for. Okay, those are two sides of like a scale, and whenever you see that equal sign, it's balanced. Now, if I want to do something to get that x by itself to figure it out, what I have to do is I have to do the same thing to both sides. So if I divide both sides by 2, I can solve this, right? Because what was happening here between the 2 and the x was multiplication. So to undo that, I can divide it. But whatever I do to one side, I have to do to the other side, right? So if I do that, I get x is equal to 9 halves, which is 4.5, right? So 4.5 or 4.5. Okay, so whatever you do to one side of an equation, you must do to the other side. Number 2, second golden rule is we're always trying to isolate the variable. We're always trying to get the variable by itself like I did here. To get a variable by itself, we're always performing opposite operations to eliminate other terms. So again, like I showed you here, this was multiplication. To get that x by itself, I had to perform the opposite operation of multiplication, which is division. Okay, and the opposite operation of addition would be subtraction, right? So let's do some of these. The goal here, example 1a, is to get the variable, which in this case is g, get g all by itself. So we're trying to get this guy all by itself. So right now, if I look at that, the thing that's happening between the g and the 25 is that it's subtracting, right? So we're subtracting 25 from g there. If I want to get g by itself, I have to do the opposite. So I'd have to add 25. Okay, so if I add 25 to this side of the scale, I have to add 25 also to this side, if you want to think about it like a scale. So if I do that, the negative 25 plus 25 goes away. Okay, that just cancels. And what I'm left with on this side is g. That's the goal of algebra, is we're trying to solve for a variable. And on the other side, what I'm left with when I add 25, I get 138. Okay, so notice, if you want to check yourself now, we can plug it back in. So we can say, okay, 113 is equal to 138 minus 25. And you can check to see if that's true. If it's a true statement, then you know you did it correct, right? Which this is, by the way. So, if you guys need to see it, boom, there you go. Did it longhand. All right, anyway, example 1b, the goal here is to get j by itself. Okay, so what's happening between j and the 87? It's being subtracted, so I need to, hopefully you're saying, add 87 to both sides. Okay, so when I do that, this goes away. Negative 3 plus 87 gives me 84. And I'm done. J is equal to 84. Okay, example 2a. Let's look at this one. So here, again, the goal is to get the variable by itself. what's happening right now with this variable? It's being added to 27. So I can subtract 27 from both sides. And then this goes away, and I'm left with k is equal to 3. Okay, and if I plug that back in, it should work. 27 plus 3 does equal 30. So it works. Okay, so let's look at 2b. For this one, again, here we go. Trying to isolate this guy, get it all by itself. So I have to subtract 16 from both sides. P then is equal to negative 12 minus 16 is negative 28. And we're done. All right, then for example 3, we get into some fractions, which makes it look a lot more scary. But really, it's not that bad, guys. So here, a couple ways to think about this. First of all, I always like to explain what's really happening here. We have a fraction, which is a division problem, but it's being multiplied by my k, my variable, because it's right next to it, right? So this is a multiplication piece. 3/5 is being multiplied by k. Okay, so to get k by itself, I would need to divide both sides by 3/5, right? So divide both sides by 3/5. So if I do that here, this is going to go away, right? Because it's an opposite operation. And on the other side, if I'm dividing by a fraction, all right, you guys, hopefully you remember your rules. If you divide by a fraction, you just flip it and multiply, right? So what that looks like here is I would say k is equal to, whenever I'm using fractions, I like to make both of my numbers fractions. So 6, I can turn 6 into a fraction just by putting it over 1, right? Now if you want to see what's happening, what's really happening is I'm taking 6 over 1 and I'm dividing it by 3 over 5. But again, if we go back to our rules of when we're dividing by a fraction, we really are flipping things and multiplying. Okay, so this would be k is equal to 6 over 1 times 5 over 3. Then I can do a little bit of simplification here, and I get k is equal to 10. All right, and then you might want to check that out and see if that's legitimate. Is 3/5 times 10 over 1 equal to 6? Well, let's look. 3 times 10 is 30. 5 times 1 is 5. Is 30 divided by 5 equal to 6? Yes. Okay, so there you go. You can check yourself very easily. Here, same deal, right? This is being multiplied by b. To get b by itself, I must divide by 2/3, which is the same thing as multiplying by 3 over 2 to both sides. Okay, so they mean the same thing because you divide a fraction that you're really flipping it and multiplying. Okay, so if we think about it like that, we can multiply both sides by 3/2. So we have 3/2 times negative 1/4 is equal to b. If I do that out, I get negative 3 over 2 times 4 is 8. And we're done. So that's example 3b. The last one that we have, you guys, is a word problem. So example 4 in your books today, when you get to example 4, it's probably going to be a word problem or two that I'm going to give you guys. So here it is. Let's look at it. It says Allison is making a stained glass window. Her pattern requires that 1/5 of the glass be blue. So 1/5 of the glass is blue. Okay, she has 288 square inches of blue glass. Okay, so there's 288 inches squared of blue. If she intends to use all of it, how much glass will she need for the project? Okay, so we're basically saying that 1/5 of all of the glass, okay, is blue. And I happen to know what 1/5 is because they told me it's 288. So I can say 1/5 of glass, G, is equal to 288 inches squared, right? Okay, so to get this, so that's the hardest part of this whole thing, you guys, is setting that up, right? Is coming up with that. Then what you should be able to do is you should be able to solve this easily. What's happening between the 1/5 and the G? It's multiplying, right? So I need to divide both sides by 1/5, or that's the same thing as multiplying by 5, right? So if I multiply both sides by 5, I end up with, let's just do this longhand, 40, carry the 4, that's 44, carry the 4, that's 10 plus 4, which is 14. So altogether, we need 1,440 inches squared of glass. Okay, so that's a real world problem. Again, very important when you guys are doing these word problems. Just get out of the word problem, and I always like to write down, I like to write down the things that are important as I'm reading them. So get that information out, and then it's turning that information into an equation that you can solve. All right, guys, that's it for this time. We'll see you guys next time in class. Peace.